Okay, our Unit 2, Section 5 notes are proofs that are not valid. So all it takes is a single error in reasoning or assumptions, and that'll destroy a deductive proof. So this results in an invalid conclusion. So some common errors that we see in deductive proofs are things like you're starting off with a false assumption or generalizations. So remember, our deductive reasoning starts off with like a general assumption, truths, and then if that is wrong, everything that follows is going to be wrong. Or an error in reasoning. So for example, an error in reasoning would be something like dividing by 0. So anytime you divide by a 0, that is an error. If you do that in your calculator, you get error. You can't divide by 0. It's like you're trying to take a certain number of things and basically you make them disappear. Okay, so that doesn't work. That would be like an error in reasoning. Another common error would be like an error in your calculations. So instead of doing, say, 4 squared, you do like 4 times 2, right? So this means it should be 4 times 4, not 4 times 2, and that is one of the most common calculation errors that you usually see. Then the last one is faulty logic. So one example of faulty logic is using circular reasoning. So you're assuming something is already true that you're trying to prove. So you're trying to prove it and you're assuming that it is already true. It leads you into kind of a circular argument. So, circular reasoning works because circular reasoning works because circular reasoning works. Okay, you're just looping around on yourself, and you're making use of what you're trying to prove in your argument. Okay, so our first example is what type of error is occurring in this deduction. So all people are over 65 are retired. Leroy is over 65, so he is retired. Now, basically this one is we're starting with a false assumption or a false generalization. Not everybody over 65 is retired. So our error here is just we have a terrible or a false assumption. So we are starting with something that is not true. So this right here is not true. Some people over 65 are retired, but not all people over 65 are retired. So this is false. So false assumption. Our next example, we have Bev claiming that she can prove that 4 equals 3, and here's her proof. So we're supposing A plus B equals C. So this is what we are starting with. So we are saying that A plus B equals C. Okay. Next, she kind of just has some sneaky forms of 1. Okay, so 4A minus 3A, I get 1A. Okay, so she's just writing 1A in a sneaky form. So here we have A in disguise. So 4A minus 3A, yes, that's 1A. So yeah, that's okay. Then we have 4B minus 3B. Yep, that's 1B. Okay, so there's like a sneaky form of B in disguise. And here in C, we have 4C minus 3C, which yes, indeed is 1C. So far, everything looks okay. Next step. So it looks like we're just moving our variables with 4 coefficients over to one side and our variables with 3 coefficients over to the other side. Okay, so taking this 4C, subtracting 4C to now get it onto this side. Same thing with our 3's. So then adding 3A, and what I do to one side, I have to do to the other. So adding 3A. Same thing here. So minus 3B, getting it to the other side, I'd add 3B. So add 3B. So then we have our 4A plus 4B. So 4A plus 4B, and then minus this 4C. And then we have this gone, this gone, gone. We have 3A over here plus that 3B, and then minus this 3C here. Okay, so everything looks okay in that step. Next, they're taking out greatest common factor from this 4A, 4B, and 4C of 4. Okay, so taking out that common factor of 4, we get 4 times, and then A plus B minus C. Okay, same thing over here, right? So taking out that GCF, right? And then how we get from this step to the next one. So far everything kind of looks okay. And then we end up with 4 equals 3. So what must have happened is, all right, so we're trying to say get all my A, B's, and C's over to one side. So I can, if I was trying to get like this, rid of this 3, I'd divide it, right? Because it's 3 times this. But I want to get rid of my A plus B minus C. So divide by A plus B minus C. Then divide by A plus B minus C. Okay, so now that's gone, that's gone. So I have A plus B minus C over A plus B minus C. So that's just a sneaky form of 1, right? Okay, so that's like 4 over 4 or x over x. That's just itself over itself. So sneaky form of 1, sneaky form of 1, and I end up with 4 equals 3. Okay, now our problem is kind of hard to see because it's hidden a little bit in some mathematical operations, but it is this step right here. So one of our errors, our common errors, is dividing by 0. Okay, so if I take a look a bit closer at this last step here. So I have an A plus a B minus a C divided by A plus B minus C. Now, if I go back up to my original premise, it's A plus B equals C. So this is one thing that I am saying is true. A plus B equals C. Okay, so if I have A plus B minus C, well, A plus B equals C. So I have C minus C, which is 0. It doesn't matter what it is. So this is like 2 minus 2. I get 0, right? So I have a C minus a C. And here's another. So A plus B is C. It equals C. So I have A plus B equals C. So I have C minus C. So I have 0. So I am dividing by a 0 in this step, this second last step here. So since A plus B equals C, A plus B minus C will equal 0. So my error in reasoning is I'm dividing by a 0. So dividing by 0, I am not allowed to do that. So this proof is invalid. 4 does not equal 3, invalid. In example 3, we have Liz, and she claims that she has proved that negative 5 equals 5. So this is what she's saying that she's trying to prove. So first she assumes that negative 5 equals 5, and then she squares both of those things, which is valid. Like you can, as long as you're doing it to both sides, it's fine. So negative 5 squared, negative 5 times negative 5 is 25, positive 25, and 5 times 5 is 25. So yeah, these two numbers do equal each other, but there is an error here. So our error is that we are starting by assuming that negative 5 already equals 5. Okay, this is the thing that you're trying to prove. So you're trying to prove that negative 5 equals 5, but you're assuming it's already true in the start of this proof. Okay, so we're starting with a false assumption. All right, so since Liz begins with a false assumption of the thing that she is trying to prove, everything that comes later is completely invalid. So Liz's proof is based on something that isn't true. Therefore, the conclusion that she reaches is also not true. Okay, so as soon as you're using that, using the thing that you're trying to prove as an assumption in your proof, that is some circular reasoning. All right. Our last example, number 4, we have Jose trying to prove the following number trick. So first you choose any number, you add 3 to it, you double it, you add 4, you divide by 2, then take away the number that you started with. So each time he tries the trick, he comes up with 5, but his proof doesn't show that the answer should just be 5. It's like whatever his number was plus 5. So there has to be something wrong here. Okay, so he's tried it out a bunch of times. He always gets 5, but the proof shows that it should be whatever number he picked with 5 added to it. So let's see where the error is. Okay, so here's his proof over here. When I'm doing these questions, I like to just do it by myself instead of trying to figure out from these steps where Jose went wrong. So I'm going to ignore these. I'm just going to box them up and then see where my proof is going to differ from his. Okay, so first I'm going to choose any number. All right. Okay, choosing a number. I'm going to add 3 to that number. Okay, so here's my number plus 3. I'm going to double my number. Okay, so whatever I get here needs to be doubled. Okay, so I'm going to double it. So I get 2x and then plus 6. Okay, so 2x plus 6, great. So that's it doubled. And then I'm going to need to add 4 to that. Okay, so adding 4. So I get 2x plus 10. Now I need to divide by 2. All right, so I need to take 2x plus 10. I'm going to divide that by 2. And then that is, so 2x divided by 2 is x. And then 10 divided by 2 is 5. So I get x plus 5, right? So this would turn into that. I have to divide both of them by 2. Okay, and then take away the number that I started with. So the number that I started with was x, right? Any number. So minus x, and I end up with 5. So let's take a look at how that differs. So I get 5, great. Let's see how that differs from what Jose did. So far, taking a look, starting with the number x, okay, that stuff was okay. Then we had x plus 3, okay. And then we multiplied that by 2 to get 2x plus 6, okay. Then we had 2x plus 10, yeah. Then 2x plus 5. Oh, and I just have in that step an x plus 5. So taking a look, what Jose did is when he divided by 2, he did our last term, divided that 10 by 2, but forgot to divide this 2x by 2 as well. So then he had 2 x's left over here. And then when he took away 1x, when he took away the number that he started with, he was still left with 1x here, and then plus 5. So this right here is just a calculation error that Jose did. Okay, everything else was right. He just made a little error in calculation, so he did not end up with 5. He ended up with x plus 5 because he forgot to divide by that 2. Your assignment is page 42, numbers 1, 3, 5, 6, and 7. And if you get finished with that and there's still time left in class, you can try number 10.